Hello and welcome to our webinar today. My name is Tim Schöllmann and our topic today is wind turbines, higher power with the matching technology. Wind energy is one of the essential keys on the way to a more sustainable energy supply that is independent of fossil fuels. In 2020 alone, 743,000 megawatts of wind capacity were installed worldwide. The trend in wind turbines is towards more and more power. That, of course, places special demands on turbines and technology. What exactly that means, I'd like to discuss today with my colleague Dirk Ehlert. Dirk, it's good to have you here today. I would say we start with a short introduction of yourself.
Yeah, thank you very much. My name is Dirk Ehlert. I'm with KEB for roughly 2.5 years now. I am in the team for integrating our frequency inverters, motors, brakes into the wind turbines of our customers.
All right, and to begin with, even though renewable energies are currently more relevant than ever, the wind sector itself is not quite that new to KEB, right?
Yeah, exactly. We started off, I think, about the 2000s, where the wind business started growing. We designed our standard inverters into the wind turbines and had a good view what was working and what wasn't. And soon we noticed that, especially for the pitch application for turning the blades of the wind turbine, there are very different special requirements. So we decided to develop an own pitch inverter for exactly this application. And this has been working very well for over 10 years now. And for our latest idea, we are trying to keep up with the big wind turbines with the highest power, and thus designed a pitch inverter with more power.
Mm-hmm. All right, and I think we'll talk about the pitch inverter later on.
Yeah, right.
But let me start with the question, which systems does KEB supply and what are the basic requirements for drive and brakes? And maybe we can start with a look at the brakes.
All right. Yeah, so basically what I like to mention first is we have a difference in the rated power of the wind turbines for offshore and onshore applications. Onshore applications or onshore turbines are generally speaking a little bit smaller. We're talking about 5 megawatts at the moment, which will also rise in the future. For offshore turbines, we are reaching levels of 15 megawatts. So there's a huge difference in that power. Also, there's more differences for offshore and onshore turbines. Offshore, you have the salt spray everywhere going around. This is what you do not have onshore, but onshore you maybe have different installation heights. So we need to consider that onshore turbines will be put up to 3,000 meters above sea level. So this is also a requirement. You ask for the special requirements for the brakes. This goes along with the environmental conditions. There are very harsh environmental conditions for wind turbines. More are compared to the standard industry application. So we have higher vibrations. We have definitely higher temperature range where the turbine has to work. Up to minus 45 degrees in the harbor is possible. So this is all conditions the brake has to cope with.
Yeah. And what does it look like for the electronics? So what are the requirements that are placed on the electronics?
Yeah, all right. Basically, the same environmental climatic conditions apply there as well. High vibrations, high temperature range, and so on. For the electronics, it's also very important to have a simple integration of the system into the turbine, to have a maintenance-friendly system, to have a robust system which does not break down a lot, but this also again applies for the brake as well.
Mm. All right, then let's now talk about pitch and yaw, which are central functions on which KEB has concentrated. And yeah, what does it take for brakes to perform these functions in a reliable way, especially under these harsh environmental conditions you already mentioned?
Yeah, generally speaking, most of the time we apply spring-applied brakes on wind turbines. For the yaw application, we use the Series 38. This is a CCV suitable IP55 protected brake, and we have it in every range possible from 1 Newton meter to 1,500 Newton meters, which is not necessary for a turbine, but we can use it. For the pitch application, we use another series of brakes. So we use the Series 20H, which is also CCV suitable for the cold climate. There we have the IP protection class up to 66, which is necessary, and we have it also in a wide torque range from 5 Newton meters to 750 Newton meters available.
And what about the drive technology? What is necessary right there for pitch and yaw?
Yeah, right. So for the pitch inverter, as explained at the beginning, we have a very compact design. So it's very important to have a robust system that is very small to be implemented quite well in the rotor hub. We have several power sizes designed so that we can equip every turbine, and I think every detail necessary is maybe extending the range of this webinar. But maybe I can say 1 or 2 sentences for the yaw application. There the situation is a little bit different. We can use our standard drives because it's not that safety relevant application. But the thing with the yaw application is that we have many motors working together to turning the nacelle. So it is very important that all these motors are working together and not against each other. And there are certain effects like gear backlash and so on have to be controlled. And this is what we are doing with a function block we designed, which is running in our controllers and is making our drives work in a way the customer wants it.
When you're talking about the standard drives, you mean, for example, the CombiVert F6 series, right?
Yeah, for example, it's F6, S6,
all right.
depending on the customer requirements. Yes.
And one important aspect for wind turbine builders is maintenance. And here KEB offers a practical approach that looks at the brake. And to understand this better, perhaps you could first describe how maintenance is carried out in a conventional way.
As you can imagine, turbines are standing very remote places, so it takes huge effort to do maintenance there. So it's very important to do as less maintenance as possible. In the past, we tried to have remote access possible and to get as much information via remote as possible to do the service intervals or to start up the turbine again or to solve the problem remotely. And one issue we had exactly was with the brake, because we did not have really information how the current status of the brake is. Because we basically could not look into the brake. So the idea before was just to have a rough estimate. Okay, in this time period the brake will maybe crash, so let's do a maintenance and change it.
And to make this easier, KEB has established a new way of maintenance.
Yes, exactly. This applies for the pitch inverter, where we have a current and voltage controlled brake output. And with this, we can have a routine that we implemented. And within this, we can, during service intervals, check the status of the brake. So it is possible to roughly estimate, okay, the brake is still in good shape, or maybe needs change in the next service interval, or needs immediate change. And there we can, offer huge benefits for our customers, because We can reduce downtime with this in case the brake would crash in an unfortunate case and not expected case. And also the brake must not be changed before its end of life. So we also reduce costs, operating costs for our customers.
So we have notable simplifications in terms of maintenance, and yeah, you already talked about it. The requirements of the plants are quite different. How does KEB meet this?
Yeah, we as KEB are a solution provider. We provide the brake, we provide the motor, the inverter, and also the chokes and everything necessary. And this can be scaled because we have different sizes of the inverter available, different motor sizes and brake sizes also available. And the customer comes to us with their requirements on load distribution and so on, and then we design our system accordingly into their turbine.
So it means that there is a high degree of variability, and yeah, maybe you can describe that variability with an example.
Yeah, sure. Yeah, well, we talked a lot of brakes today. One example for a brake modification would be a surface brake, which we designed for one of our customers to have a small building place to be able to integrate the brake into the motor. This would be one example. Maybe another example for brake adaptation would be the adaptation of a brake on the A side to allow a better mounting between the gearbox and the motor.
All right. And as I said in the beginning, wind energy already plays an important role in energy supply. And if we now dare to look into the future, where is wind energy heading, and how is KEB preparing for this?
So all in all, what we see is increasing energy demands, and also everybody wants to have cheaper energy. So the answer is kind of to build bigger turbines, because then you can reduce the cost per kilowatt hour produced. And this is a trend we are also following, also with our newest development, 23P6, the big pitch inverter, also now UL certified. And I think this is the basic direction where we are going. We expect growth in the wind energy sector due to the growing demand for renewable energies, a more eco-friendly future. This is for our electronics part. Maybe this roughly applies for the brakes as well. We will do more adaptations in the future. For example, we are working on a development of more robust, reliable, and brakes with lower current consumption and so on. This is something we can be looking forward to.
All right. So, and when the time comes, when new products are released, you will of course hear about it from us directly. For example, in our newsletter, which you can subscribe on our website for free. And I think we're at the end of our webinar today. I'd like to thank you, Dirk, for being with us today.
Thanks for having me. Yeah.
And thanks for watching. It remains for me to refer to our Tech Tuesday website. You find interesting topics of a wide range of areas right there. Thank you, and we hope to see you soon.